Hello, students. We are now into the unit of solving equations. So I'm going to look at the most basic type of equations that we can solve today. All right, so these are going to be what are called one-step equation. Why are they called one-step equation? Well, because we should be able to solve them in just one step. So you're probably going to be thinking, oh, I can do most of these in your head. Okay, and you probably can do most of these in your head. For example, here's my first problem. It says 11 equals 5 plus w. So what this equation is saying, first of all, it is an equation because it has an equal sign. All right, so it's saying this value on the left-hand side is equal, so it has to be the same as the value on the right-hand side. All right, so you could probably do this in your head because you could think of it like this. 5 plus what number is 11? All right, so 5 plus how many more is 11? Now, if you need to, you could get out your fingers, okay? And 5, you're starting off with 5. How many more would you have to count to get yourself up to 11? And you can probably figure out pretty quickly that that answer is going to be 6. All right, so yes, you could do this problem in your head. However, I want you to get used to the process. So I'm going to be looking for work pages where you are showing your work, even for these basic equations, because eventually we're going to have equations that look like this, where we would have 11 equals 5 times the quantity of w minus 3 minus 2 times w. All right, so equations like this, we can't just do in our head. All right, so we need a process. So we need to get used to that process right now where it's basic. We're going to start off small, and then we're going to just continue, and we're going to build off of this, and we're going to keep using the same process every time, but our equations are just going to slowly get a little bit more complicated. All right, so here's how you're going to show your work. All right, so you'd write off on your work page. If you want to type it, you can type it, but you would write down what the original equation is. So 11 equals 5 plus w. And then what you would do, okay, is you are trying to undo, okay? So we have two sides of the equation, okay? I can split those sides up with a line down the equal sign. We have the left-hand side, we have the right-hand side. The left-hand side just has a number on it. We want to look to find where the variable is. So here's the unknown value, the variable. On the right-hand side, we are taking 5 plus this unknown value. Okay. So we want to get rid of this 5 plus. We want to get rid of this 5 that we're adding to w. So how do you get rid of addition? Well, what's the opposite of adding? It's subtracting. So what we're going to do on this side, instead of adding 5, we are going to subtract 5. Okay, now if we're going to subtract 5 on one side of the equal sign, okay, to make it so this is equation, it needs to stay balanced. If we're going to subtract 5 over here, we'd have to subtract 5 over here. All right, so back to the right-hand side. 5 minus 5 cancels out. That's going to leave us with a positive w. Now you can put a plus sign here if you want. I wouldn't suggest it. Okay, we don't normally put a positive sign put in front of a 6. If it's a positive 6, you just put 6. So I would just put w. And then on this side, we have 11 minus 5. So 11 minus 5 would give us 6. All right, so w equals 6. 5 plus 6 equals 11. And this is how we show our work. And this is what I'm going to be looking for on a work page. So on a work page, you'd put your name. And then you'd put that this is homework. Well, you should also probably put what block you're in. All right, so let's say hypothetically I'm in block 1. And then this is homework number 5. So put the name of the homework assignment. And then next to this problem, you'd put that this is problem number 1. Show your equation, show your process, show your answer, and then type your answer into Alex. All right, so let's go ahead and do another problem. All right, so for this problem, now we have -2. So let me go ahead and write this down, show my work. All right, so this is problem number 2. All right, now I have -2 is equal to, sorry, that doesn't look very good, is equal to x minus 3. So x minus 3. All right, so now what I'm going to do is I'm going to split. I'm going to find where the equal sign is, and I'm going to split the left-hand side from the right-hand side. Now I pick whichever side has the variable. All right, so this side, the right-hand side, once again has the variable. I need to think of what number minus 3 gives me negative 2. Again, you might be able to do that in your head, but we need to focus on the process. So what number minus 3 gives us negative 2? Maybe I can't think of it. So what I need to do is I need to undo what's on the same side as the variable. So right now I'm subtracting. I'm taking x minus 3. Well, if I need to undo it, I need to do the opposite. And the opposite of subtracting 3 is addition. So I would add 3. So minus 3 plus 3 is going to cancel out. But if I'm going to add 3 on the right-hand side of my equation, I also need to add 3 on the left-hand side of the equation. All right, so a minus 3 plus 3, that's going to cancel out. That's just going to leave me with x on the right-hand side. And on the left-hand side, I have negative 2 plus 3. All right, so different signs. So 3 minus 2 would give me 1. 3 is larger than 2, so I keep the sign of the 3, which is positive, so this gives me 1. So x equals 1. Let me plug that back in and double check. So is 1 minus 3 equal to negative 2? Yes, it is. So my answer would be 1. All right, for the next problem, don't let fractions scare you. This is why we started off with the first unit that we did. So then we worked on remembering how to add and subtract with integers as well as with fractions, and we also were focused in on our order of operations. All right, so what I would do is copy down problem number 3 on my work page. All right, and then I would find the equal sign. I would draw in the dividing line that splits my left-hand side from the right-hand side. Find which side has the variable. So now the variable is over here. So now I need to think of what operation am I doing to y? Well, I'm subtracting 1/3. What is the opposite of subtracting? Well, it's addition. So instead of subtracting 1/3, to move it to the other side, I need to do the opposite, which would be to add 1/3 to both sides. All right, so on the left-hand side, negative 1/3 plus 1/3, they cancel each other out, leaving me with just y equals, and then on the right-hand side, I need to add these together. I need to combine them. All right, so this is again why we practiced with adding with fractions. So off to the side, I'd show my work for this. All right, so I'd have negative 2/5 plus 1/3. First thing that I need to do is I am adding with fractions. So I need to get common denominators. So 3 and 5, 15. That's my least common denominator. So I need to multiply my first fraction by 3/3. And I need to multiply my second fraction by 5/5. All right, and that's going to give me negative 6/15 plus 5/15. And that will be equal to, remember, once you have common denominators, you keep the same denominator, which is 15, and you add the numerators. So negative 6 plus 5, those are different signs, so I'm actually going to subtract. So 6 minus 5 would give me 1, and then keep the sign of the larger value. 6 is larger than 5. The sign in front of it is a negative, which is going to give me that y is equal to negative 1/15. All right, so then I would type this into Alex, and the way I'd type that in, I would type in negative, and then here's the fraction, and then I would type in my 1/15. So for my next problem, this is problem number 4. So I'd put down problem number 4. I'd write down the equation, 52 equals 4v. Okay, and then I'm going to split the left side from the right side. So I'm going to draw in that dividing line. The left-hand side doesn't have a variable on it, but the right-hand side does. So now I need to think of what operation am I doing to that variable. Well, I have 4 and then a v with it. No sign whatsoever, so that means it's implied multiplication. So 4 times this number gives me 52. So I want to undo this. So I need to do the operation that undoes multiplication, which is division. So if instead of multiplying by 4, I'm going to divide by 4. And if on my right-hand side I divide by 4, on my left-hand side I also have to divide by 4. So multiplying by 4 and dividing by 4 cancels out. That's just going to leave me with v on the right-hand side equals, and then 52 divided by 4. Feel free to use a calculator now in the second unit if you'd like to. So 52 divided by 4, 4 goes into 5 one time, remainder 1. 4 goes into 12 3 times. So v would be equal to 13. Double check. 4 times 13 does in fact give me 52. All right, so for the next problem, I have problem number 5, and I write my equation, 9 equals 27n. Or I can say that as 9 equals 27 times n. So I'm going to split the left-hand side from the right-hand side. Left-hand side only has a number, but on the right-hand side, there's this variable. So I want to undo whatever's on the same side as my variable. Right now I have 27 times n. So what's the opposite of times? It's divide. So I'm going to divide by 27. I'm dividing by the number that's on the same side as n. So now I'm going to divide both sides by 27. Going back over here, 27 divided by 27 is just 1. It cancels it out, which just leaves me with n. Equals, don't lose your equal sign, and then 9 divided by 27. So 9 over 27, the smaller number's on top, which means this is going to stay a fraction. However, I always look to simplify my fraction. So 9 and 27, what are they both divisible by? They are both divisible by 9. So that's going to give me 9 divided by 9 is 1. 27 divided by 9 is 3. So my final answer, simplified form, is 1/3 equals n, or n equals 1/3. Feel free to use a calculator. Feel free to use Desmos. That's going to be the calculator that you're allowed to use in this class. And so again, what we were doing was we were taking 9. I know it's smaller, but that's what we had. Go with what your work showed. Oops, where's my work? It's down here. Here I had 9, and I was dividing it by 27. So here in Desmos, I would type in 9, and then I'd hit the divide by button on my keyboard, and then I'd type in 27. Okay, and you're going to see right here that it gives me 0.3 repeating. Now, Alex doesn't want me to type in a decimal. The only option was to type in the fraction. So over here, there is the convert to a fraction option. So I'm going to convert it to a fraction, and there it gives me 1/3. So feel free to use a calculator if you would prefer. All right, but this would be the required work that I need to show whether I use a calculator or not. All right, so next question. Same thing, okay? I would write down question number 6, and then I'd write down my equation, and then I would need to solve it. All right, so I'm going to split my left-hand side from my right-hand side. Okay, the right-hand side is where the variable lies. So then this is the question, the all-important question, is what are we doing to the variable? All right, this one's a tricky one because we have a -4 with it. So you're going to be inclined to think, okay, opposite of a -4 is a +4. So the mistake is going to be that you're going to add 4 on both sides. You need to ask yourself, what am I doing to the variable? Read this problem. -4u, or -4 times u. All right, so what we're doing to the variable is we're multiplying by -4. And the opposite of multiplying is not adding. The opposite of multiplying is dividing. So instead of multiplying by 4, we're going to divide. And it wasn't just 4, it was a -4. So we're going to divide by -4. And over here, we'd also need to divide by -4. All right, so the -4 divided by -4 would cancel out. I'll bring down my equal sign. I'll bring down the u, what remains from the right-hand side. And then negative divided by negative is positive, and 12 divided by 4 would give me 3. So 3 equals u, or u equals 3. Again, feel free to use a calculator if you'd like. All right, I'm going to skip ahead to question number 8. Question number 7, just keep doing what we've been doing. Question number 8, so here's number 8. I write down the equation. All right, and then I find the equal sign. I split the left side from the right-hand side. Here's my variable. What am I doing to it? I am adding 1/2. So what is the opposite of add? It is subtract. And what am I adding? 1/2. So what do I need to subtract? 1/2. So if I subtract 1/2 over here, I need to subtract 1/2 over here. All right, now 1/2 minus 1/2 cancels. That's going to leave me with v equals. And now I just have to go through and solve this problem right here. I need to evaluate. So 3 1/4 minus 1/2. Feel free to use a calculator, but if you're going to use Desmos, you need to convert this mixed number into an improper fraction. So just a quick reminder on how to do that. You have 3 whole numbers right here, or you have a whole number of 3, and the fraction was 4, so 3 times 4 would give you 12, so you have 12/4, okay, plus 1 more, which would give you 13/4. All right, so this value, improper fraction, is the same thing as 13/4. And then feel free to do this off to the side or go and grab a calculator. All right, so here I am in my calculator, and I want to type in 13/4, and then I was subtracting So when I type in subtract, make sure I'm subtracting the entire fraction. So I'm subtracting 1/2. All right, that's what I had, I believe. All right, so 13 over 4 minus 1/2. Yes, it is. So 13 over 4 minus 1/2, that's the decimal 2.75, which I could type in that way if Alex would have let me. However, it's going to want a fraction instead, so I need to convert this to a fraction, which is going to give me 11 over 4. All right, so that gives me v equals 11 over 4. So v equals 11 over 4. Here I'm going to work on translating a sentence. So here is your English sentence into a math sentence, which is an equation. Remember, every equation has to have an equal sign. The keywords for an equal sign would be equals or the same as or is. All right, so now I'm going to go through and we're going to take this sentence as it is, and I'm going to try to translate each part of it into mathematical symbols. So the product, what operation does that mean? So does it mean add, subtract, multiply, or divide? Product, it means multiply. So the product, notice I'm not using an X here. You should be done using X as a symbol for multiplying because in algebra we use X a lot for our variables. So instead I'm going to use this dot to represent multiplication. So the product of, all right, so this is telling me what I'm going to be taking the product of Holly's savings and, all right, so here's the keyword and, this is telling me where that multiplication sign goes. So Holly's savings, which down here it says use the variable H to represent Holly's savings. So I'm going to take H. And, so now this is where the multiplication symbol is going to go. This and is telling me what I'm taking the product of this and this. So this is where it goes. So H times 6 is, so is a keyword for equals, 114. All right, so down here what I would do is I would type that in. I would type in H times, okay, now I don't like this. Alex does give you this symbol right here, H times, or if you'd prefer, H times 6, okay, implied multiplication just means you put them together. However, if you just put them together like that, the number always goes before the variable. So you could type this in as 6H or H times 6. The order that you multiply does not change anything. So that would be H times 6 or 6H is equal to 114. And then again, the nice thing about Alex is you can always click check and it will tell you if you're right or wrong. And this one would tell us that we're right. So that's how you do translating English sentences into algebra sentences, which are called equations. The last question on here, you're given an equation, and then you need to just read through all of the scenarios and think, okay, would this be the equation I need to solve for this scenario? So there were X dogs at a dog park, then 16 other dogs were brought in. So that means we're adding in 16 more. So this is X plus 4. This would be X plus 16. So this one would not be highlighted here. I would not check this off. A dog park has 4 sections. Each section has X dogs. Dog park has 4 sections. Each section has X dogs. The dog park has a total of 16 dogs. All right, so we have 4 sections. Each of them has X dogs. So 4 sections, each having X dogs. All right, so that means we'd have 4 times X, and that would give us 16. This is X plus 4. There are X dogs at a dog park. Then 4 dogs were taken away. So those were taken away. They were subtracted. This is plus. All right, the combined number of dogs at a dog park is 16. There are X small dogs and 4 large dogs. So if we take how many small dogs there are plus how many large dogs there are, which is 4, and their total number, their combined number is 16, this one would be it. All right, so you're going to select all stories. So had anything else been a possibility, would have selected that as well. If none of them, we would have selected none of the above. And then we're going to do the same thing for down here, read through the scenarios and figure out, okay, which scenario would this equation work for? You're going to hit check. And by the time that you're finished, you should have all of these problems done. Make sure that you are showing a work page for problems numbers 1 through 9. So 1 through 9, 1 through 8 especially, where you're going to actually show the steps. Go ahead and do it for 1 through 9, where you're translating your sentence into a mathematical equation. All right, and that is your introduction, our first day of solving equations. There will be lots more to come.